Hello and
Michael.
welcome back. Hi, Juan Carlos. Hola. We're continuing our 500-watt plus journey through the day. Next presentation will be given by LonGi Solar. LonGi, you probably all know, is the world's largest wafer manufacturer. For a long time, it has been the largest mono wafer manufacturer. Now it has been also for some time the largest wafer manufacturer in general. But what's probably new to many is that LonGi also strives to reach that position in the module field as well. I was pretty surprised about the ambitious targets that I read in the recent quarterly presentations. Based out of Spain, Juan Carlos is currently Senior Sales Manager at LonGi Solar. He has experience and interest in solar inverters and monitoring system. If you need to know anything from LonGi, he's your man in Europe to talk about technical aspects of solar PV design, PV module selections, and new technologies. Sales-oriented professional, he specializes in pre-sales, product management, contract reviews, and negotiations. Juan Carlos joined LonGi not long ago, but has been working in the solar industry for quite some time with other solar module manufacturers. And we are very happy to have him and hear his insights today at our event. Juan Carlos, the floor is yours.
Thank you. Thank you, Michael, for the introduction. Well, I'm going to start with my presentation. Let me share first the screen, if you're okay.
Sure.
And then this one. Is that okay? Can you see it?
It's coming. Yes, here we are.
Okay. Well, as commented, I mean, LonGi Solar is one of the biggest vertically integrated companies regarding when we talk about PV modules. As you mentioned, Michael, we are producing since the beginning of the whole chain till the end, till the modules. We are well known in the market since some years ago when we talk about the wafers, actually since beginning of 2000s, more or less, when we started to produce wafers, taking into account the market, the booming in especially in Europe, in Germany. And after that, LonGi was more focusing on the quality of the wafer, on the production of cells, and finally on the production of PV modules, mainly driving the market from polycrystalline technology to around 2016, from polycrystalline technology to monocrystalline technology. And we all know now that, I mean, actually, I would say 100% of the modules installed worldwide are based on monocrystalline technology, mono-PERC. This is basically thanks to this push of LonGi. Actually, all their manufacturers are following the same path. And now, at the end, the driver for us is the cost reduction in terms to reduce or improve the LCOE. This is the main driver via the technology and the efficiency, the increasement of the efficiency and the reduction of the capex and opex in this case, thanks to this higher efficiency on the modules and low degradation. Okay. Actually, we will see also during this presentation the new development of LonGi based on 500 plus modules. Actually, this is the main reason for this webinar, and especially looking to reduce a bit more the LCOE and the capex thanks to the promotion, keeping the promotion of not only the mono-PERC technology but also the bifacial technology. Okay. So let's go ahead. Well, as I said before, I mean, our main driver for the market and for our clients is to reduce the LCOE. At the end, by reducing the cost of electricity, we can be competitive in the market, or we can make our customers competitive in the market compared with other technologies available worldwide. So how we can do that? So basically by reducing the cost of the capex, and also I mean I would say here the reduction on the BOS cost will imply not only a reduction in the capex but also a reduction in the OPEX, since at the end, if we can reduce the total number of parts making the PV plant, we can reduce all the maintenance, the operational maintenance along the lifetime of the installation. But basically, we have a big impact, or we can make a big impact on the capex. All these two let's say characteristics will impact in a big way. I mean, in a positive way, the reduction of the cost of electricity. How to do that? So in this case, by ensuring that the application is compatible, so all the parts within the installation are compatible among them. I mean, in this case, and specifically with this new development on 500 plus modules, the size of the panel, the current to be driven or managed by the inverter, and the voltage to be able to reduce the cost. So these three main parameters, together with the high efficiency, so 4 parameters, will ensure that there is a compatibility with all the BOS in the installation. On the other hand, also to ensure that the module is reliable. At the end, we need to think, as we know, the warranty of the panels are up to 25 years for the monofacial solution and 30 years for the bifacial solution. So we need to ensure that the module is reliable and effective for the whole lifetime of the warranty, at least, to ensure the whole impact from a financial point of view. Okay, so basically we have the big base, or the big impact to the LCOE will be to ensure the application, the compatibility, and also ensure the reliability of the module. Okay, we will see later some comparisons on LCOE regarding different type of dimensions of the panel, and also power of those solutions, and to see how they impact directly on the LCOE. Not only that, but if we look directly on how to increase the module, the power of the module, we have many ways to do it, for sure. Increasing the size of right now, since let's say 2018 or even 2019, we started to see in the market different solutions regarding the size of the cell. At the end, by increasing the size of the cell or the wafer, we are increasing the current drive to the outside the panel. So by doing that, by increasing the current, we're increasing the power directly. Okay, but it doesn't mean that by increasing the size of the wafer or of the cell till the end, we will get all the benefits, because we need to think in many, let's say, characteristics, as I mentioned before. For instance, the VOC will be important. We'll see this later. Also the current going out of the panel, and also the dimension of the panel. We need to we have a compromise on that, especially with the new technologies based on tracker systems for 1P or 2P solutions. Okay, so one point will be to increase the module size. The other way will be intrinsic to the improvement of the technology via the reduction of the optical losses or the electrical losses. At the end, these are the two main drivers to increase the efficiency and the power of the module. Okay, so in our case, we are implementing in all our portfolio the hard cap technology, which has benefits, as we all know, regarding the reduction of the impact of the hotspots, also the increment of the efficiency thanks to the lower current, so lower joules losses in this case. And also this will be both from a electrical point of view, from an optical point of view, we have the coated glass, so just trapping more light into the surface of the cells, and also the implementation of white EVA to get a higher reflection on the space between the cells. Okay. On the other hand, on the other side, we have also improvements at the cell level by using silver paste, in lowering the resistance of the wafer, and so on. Okay. For instance, in this slide, we can see the improvement on the BOS cost when we increase the size of the wafer or of the cell. When we talk wafer or cell, we can assimilate that are both the same from this perspective, from the dimensions point of view. We can see, for instance, we can find a reduction on the BOS of around 0.14 cents per watt, $cents per watt, when we increase the power by 2%. In this case, we are comparing here G1 sizes of the wafer on the left side, on the, let's say, around 390 watts, with different other options, still the M6, which is the 166 millimeters side length, okay, for the panel. In this case, in our case, will be the Hymo 4 series, okay, that is using this M6 wafer. Okay, so we can experience an improvement on the reduction of the BOS cost by increasing the power, thanks to the size of the cell. Now for this year and of the only this year, so in Q4, we are launching our new series Hymo 5, which is based in a M10 wafer. This wafer is a 182 millimeter side length. Always we are basing, as I mentioned before, our technology in a multi-bus bar technology with nine bus bars, and also on a half-cut cell technology. Okay. In this case, I am now introducing here 3 different alternatives. Well, let's say if we see the panel from a layout perspective, we have 2 options: 72 half-cutted cells with up to 540 watts, and 66 half-cutted cells with a power in between 485, 500 watts. Okay. The interesting thing, in both cases, we have the 2 options, monofacial and bifacial, always with frame, and in the case of the bifacial solution, with a glass solution. We'll see later a bit more about this specifically about this product. Okay? Interesting thing is regarding or related to the dimensions of the panel. We see, for instance, I would like to highlight the dimensions of the 66 half-cutted cells. We are almost in the long side of the panel, below 2.1 meters. So it's pretty close to the standard, let's say G1 or a bit more G1 wafer size in terms of length. The width is a bit more, is almost is around 1.1 meters. So we can see with a small, let's say small, okay, a bit more than 2 meters. A small size on the panel, we are reaching almost, well, actually we are planning up to 500 watts for this solution for the 66 half-cutted cell, either in bifacial or monofacial solutions. With the bifacial solution, we are using also white EVA because at the end we think that we can get more, we can boost the energy thanks to the direct light on the front side rather than the rear side. So the rear side the reflection can be used on behind the panels, let's say, or also with the diffuse light available in the side. Okay. Regarding the 72 cells, as I mentioned before, we are up to 540. We have up to 540 watts with dimensions. Some dimension around 2.2 meters and 1.2 meter. Okay. Actually, the width of both solutions are the same because this is mainly based on the size of the wafer. Technology applying on this technology. Well, as I said, wafer size is new one, is 182 millimeters side length, which is known as a M10 mono wafer solution. The interesting approach is the change on the dopant from boron to gallium. This helps us to reduce the LID, the degradation of the panel. As we all know, I mean, the interaction in between the oxygen and the boron is leading to a degradation, especially with the LID degradation, so the light-induced degradation. So by removing the boron and including the gallium as a dopant, we are somehow neglecting or minimizing the impact on the degradation of the cells when we talk about LID. Okay. This solution is still based in a P-type PERC solution, since we see still, let's say, a way of improvement in terms of efficiency with this technology. Okay, since we have, I mean, we are pretty well experienced on this technology, and we have already shown the path along the years on the improvement on the power available or the power being offered to the market. Still, we are keeping, as in the Hymo 4 series, we are keeping in this new series Hymo 5 the 9 bus bar half-cut cell technology, with all the benefits they bring us to the behavior of the panel. As I said, the higher number of bus bars allows us to minimize the impact of the cracks in the event of a crack in the cells. Also to reduce the path of the current to flowing to the cell, to the internal circuit of the panel. So at the end, we are reducing the electrical losses thanks to a lower series resistance, okay, available. So we are increasing the efficiency thanks to that, and also all the benefits related to the half-cut technology. So reduction on the current produced during the normal operation. Reduction of the impact of the hot spots in case there is an event or an issue with a different irradiance for any reason. And also thanks to the layout, we allow 6 different electrical circuits. So we have some independence between them. So in the event one of them has a problem, we are not, let's say, impacting the whole panel, or at least not the 1/3 as with a normal full cell. Okay. With this model, we are reaching now, with this technology, we are reaching now a power coefficient for the power, a temperature coefficient for the power of minus 0.35% per degree Celsius, which means that we are reaching 3.5% losses due to the temperature every 10 degrees of increase. Okay. And thanks to all of that, we are reaching an efficiency over 21% at module level. Here are some key parameters. We can see here as we showed before in the previous one of the previous slides, the dimension of the panel. But what is pretty interesting here are the 3 parameters apart from the power shown to every side of the module. When we talk about the 72 half-cutted cells and 66 half-cutted cells, we can see, for instance, the weight. In both cases are a bit over 30 kilos, which is a weight that can be handled by 2 people during construction and maintenance without any problem. Another interesting parameter will be the current. We are around 13 amps, which means that is a current that can be managed by any standard inverter in the market. We know that, for instance, there are options based on 210 millimeters wafer. In this case, basically, what we are doing, as I said before, we are increasing the current produced by the cell or by the module, thanks to the larger area available. But in this case, if we think about, let's say, a half-cutted cell based on 210 millimeter wafer size, we are reaching around 18 amps, which will be somehow a bit difficult to manage by the current inverters available. Okay. And the other specific parameter and very important one in this case to reduce the VOS will be the VOC. When we design, as we all know, when we design the string length based on the VOC and the thermal coefficient for the voltage and the temperature available in the site, we need to rely on this, or we need to think about these three parameters to design the string length. So in both cases, we can see we are below, for instance, in the 72 half-cut cells, we are below 50 volts, which in some cases can allow us to at least install 28 panels per string. In the case of the 66 half-cut cells, even better, because we are around 45 volts. So we can install up to somehow, depending on the temperature of the site, 30 panels per string, which allows us directly to reduce all the electrical VOS. Okay, if we think in other solutions, normally the VOC is over 30, either over 50 volts or with a high current, which in one or another way it's impacting in a negative way the design of the installation. Okay. One of the reasons of improvement of our efficiency at module level is the use of our proprietary smart soldering technology or solution. In this case, we are using a specific ribbon with an area based in a triangular section. We can see it over the surface of the cell. This triangular section maximizes the use of sunlight because it makes the reflection of the light over the surface of the ribbon in a better way compared with a flat solution, a flat ribbon or a round ribbon. The triangular ribbon is offering a better, let's say, reflection over the surface of the cell. Not only that, this same ribbon has a section that is flat, that allows us to have a better soldering, achieve a dense soldering with lower stress on the soldering between the cells. So somehow incrementing the reliability of the panel and allowing a better, let's say, a better behavior during the expansion and contraction due to the temperature and to the ambient temperature of the site. This flat section allows us to minimize the gap in between the cells. So at the end, thanks to this improvement or reduction on the distance between cells, we are increasing directly or impacting directly the efficiency thanks to let's say, a smaller solution. Let's say at the end we are reducing the surface of the total surface of the module, the active and non-active area. So we are increasing the efficiency of the overall panel when we talk about when we calculate the efficiency of the panel based on the dimensions, the standard dimension of the solution. This is smart soldering. As we can see in this chart, on the bottom, on the x-axis, we have the temperature. This is a thermal cycle. And in this case, as I said, we have in the x-axis temperature, and in the y-axis we have the stress on the cell. We have here a comparison in between the three alternatives we can have in the market: the flat ribbon, the round ribbon, and the segmented ribbon by LonGi. And we can see here that with our solution, we have a lower stress along any temperature during the thermal cycling. That allows us to reduce the stress over the cell by 20%. So at the end, we are increasing the reliability of the panel during the entire lifetime of the installation. Also, as we promoted at the beginning in 2000, let's say since the beginning, the mono PERC technology, but with the aim to promote basically, or at the end, the bifacial technology. We can see here, I mean, we have till now shipped over the wall over 5 gigawatts of bifacial technology. And it has been verified not only by this large scale power station, but also by via some pilot projects with in partnership with some third parties, TÜV Rheinland, TÜV Süd, and RETC in the US. And here we have several site tests where we are testing our solution, our bifacial solution, taking into account different climates and also different albedos. We can see, for instance, if we look at one of these examples in the second picture, starting from the right side, Livermore, we have here an albedo of 21.4 based on gravel. That boosts the energy over plus 8.3%. Okay, thanks to the bifacial gain. Okay. When we talk about the bifacial module, we always rely on a solution based on a dual glass solution, so 2 + 2 millimeter glass, and always with frame, which allows us to offer a mechanical or to pass the mechanical load test over 5,400 pascals. Okay, the use of the frame is somehow really useful or has some advantages in terms of reliability during construction to avoid the cracking of the glass or the lamination during the handling and installation of the panels. Also allows us to reduce the cost of the installation, thanks to, since it allows us to use different clamping solutions in the market. So we can say we can use omegas or clamps if you want, or even we can go to the traditional screw plus nut, which can allow us to reduce the cost of the installation. Okay. Always, as I mentioned, we always use or rely on a solution on double glass solution, since it allows us to reduce the degradation and to increase the behavior from a mechanical point of view. All the stress transfer to the cells is minimized by this solution compared with a solution with glass and transparent backsheet. Okay. As I mentioned also about the size of the panel, we have two solutions: the Hymo 5 based on a 72 half-cutted cells that can be suitable for instance, for a 1P solution, our 1P axis tracker, okay, or with the 66 half-cutted cell with a smaller dimension that allows us, for instance, to design our installation with a 2P solution with an axis tracker, single axis tracker. Actually, I mean, the 72 half-cutted cells can be also designed or suitable for a 2P solution, but at the end it will depend, I understand, on the cost of the tracker based on the mechanical load requirement, okay, for the specific site. From an electrical point of view, it has been also optimized. So at the end, as I mentioned, the size of the cell is driving the current. So the higher size of the cell will produce more current. So based on that, we have chosen this solution based on 182 millimeter side when we talk about the cell of the wafer, because of that, to be compatible with, with the current portfolio of inverters available in the market. Okay, with 13 amps as a current, as an IMP current. Okay, and when we talk about bifacial gain, if we, for instance, I don't know, on the right side we have a table with different expected yield gain based on different albedos. So, for instance, if we talk about a desertic area with 35-45% of albedo, we can expect, depending on the design of the installation, in between an additional gain or additional yield of 10 to 15%. This will be impacting directly an additional current to be flowing to the inverters. So we are expecting to have this around below 15 amps, something like that. That, as I mentioned, will be compatible with the main inverters available in the market right now, with no power loss at the end. If we increase the current to a value that the inverter cannot manage, at the end the inverter will will enter in a derated mode, just not generating power and generating a loss that cannot be fed to the grid in this case. Also, thanks to the materials used and the reliability of our panels, we can offer the best in-class degradation warranty. For instance, for the first year, and thanks to this, to the use of the gallium as a dopant, we can offer in the market right now a 2% less than 2% degradation on the power for the first year. Actually, the value is around 1.1% will be as a realistic value. And from the first year, so from the second year to the year 25, for a monofacial solution, we are offering 0.55% per year as a degradation. And for the bifacial solution, based on a dual glass solution, we are offering up to 30 years, and a degradation from the second year of 0.45% per year. Okay, this is mainly about, for sure, about the reliability. All the soldering we discussed or we talked before, the gallium as a dopant, and also the use of glass solution, since we are not allowing one of the enemies of the lamination, which is the humidity. Okay, we are reducing the impact of the humidity within the lamination. Why the M10 wafer size, so the 182 millimeter wafer? Well, these are, we did a study on these 5 main factors about for instance, about the production and feasibility and cost. I mean, we are keeping the cost during production, thanks to the, let's say, to the dimension of this wafer size. Since at the end we have a minimum, let's say, modification on the production line due to this change. Okay. From a reliability point of view, as I mentioned also before, we have the lower LED in the market, the lower linear degradation, good behavior when we discuss about mechanical load, especially when we talk about bifacial modules, and the performance warranty we shown in the previous slide. Also, from a system compatibility regarding the BOS, when we discuss about the current, also the compatibility with inverters available in the market, and also with the 72 half-cut cells and the 66 half-cut cells, the compatibility with the tracker. Okay, keeping let's say, reduce somehow a dimension of the panel compared with other solutions available in the market, maybe based in a bigger wafer size. Also, from a logistic point of view, we can increase somehow or keep the power density for container, thanks to the dimensions of the panel, so we can lower the impact of the transportation cost, which is also important. And also during the handling of the panels, the module installation, not difficult for 2 people to install, since I mean the panels are a bit more over 30 kilograms, both options, with an area of a bit more than 2.5 square meters. Here, when I would say this is the most interesting part of the presentation, the comparison with other solutions available in the market, comparing our Hymo 5 solution based on, for instance, in this case with a 540 watts module, compared with a G1 solution based on for 410 watts, so based on a 158 millimeter wafer size. Okay, we can see, for instance, here all the saving costs based on an installation in China of 4 modules in landscape in a fixed structure. Okay, we can see here BOS cost reduction of more than $1.2 per watt. And for instance, just to highlight, the manual cost is reduced on over 10%, actually 20%. And from an electrical point of view, if we combine the combiner box and the cable, over around 35%, okay, which is, I think, a good number. If we make a wider comparison and showing all the available solutions in the market right now, we have here the G1, we have here the M6, we have also the M10, and we have also the M12 here. For instance, we can see we take as a reference the G1 solution based on a 410 module. Okay. An interesting thing is we can see the efficiency, for instance, of all of them. Hymo 5 is over 21% efficiency. This is thanks to all the technological solutions we have implemented in this new module. Smart soldering, so reducing the stress on the cells, reducing the gap between cells, increasing the reflections thanks to the triangular ribbon. What else? The adoption of the 9 bus bar solution with half-cut cell, and so on, and also the implementation of the gallium arsenide dopant, okay, instead of boron, available in the market right now. So with our solution, we are increasing the efficiency, boosting the efficiency over 21%. And one interesting thing will be, for instance, the string length and the relation with the VOC. We can see here that the most part of the solutions available in the market are over 50 volts, which this is related directly with the string length. We can see here that we can, with the higher power beam right now, 540 watts, we can offer 28 panels per string. For sure, it will depend on the location and the specific temperature available in the site. But as a reference, all this has been calculated on the same, within the same, let's say, or under same conditions. So we can see here that we can install, for instance, one additional panel compared with a solution based on a 210 millimeter wafer, which at the end, this is impacting positively on the reduction of the BOS cost. We can see, for instance, if we compare the Hymo 5 72 half-cutted cells with a M12 or 210 millimeter wafer size, we are reducing the BOS cost of around 0.34 cents. Okay, which is not bad. But maybe the interesting one here will be the Hymo 5 66 half-cutted cells. We can install up to 30 panels per string. So we are reducing the number of strings dramatically compared with other solutions. For instance, with the panel in the second column, the one based in the 163 millimeter size for the wafer with 465 watts, we are increasing the number of panels by 4 per string, which has a big impact. We can see is almost half the cost reduction compared with this solution. Okay. And just to summarize everything and to highlight all the benefits of the Hymo 5 series, as I mentioned, I mean, we are reducing the logistic cost. Basically, we can lower it by 10% compared with a mainstream solution. If we mix the electrical impact and the mechanical impact, we can reduce. I mean, first we can match all the string inverters or the main inverters available in the market by reducing the cost per watt. Also, we are able to reduce the racking, the pile foundation, and all the cabling and combiner boxes thanks to this solution, and also to the labor cost thanks to the weight provided by these two solutions. Okay, all this, as I mentioned, will reduce the labor cost and basically also will boost the power generation. So combining the reduction in capex and opex and the increment in the power generation, thanks to the different solutions applied in this technology, we can reduce the cost of the LCOC, which is basically our aim since the beginning, and we would like to be part of this improvement along the time. Okay. So from my side, that's all, Michael. Thanks a lot.
That was actually really a lot, Juan Carlos. Thanks so much. I think that was very insightful. I think that leaves almost hardly any questions because you answered almost everything in your presentation. I think there was still some. One from my side, can you just elaborate a little bit once again on, I think you didn't show that, on your expansion plans in generally, so where you are, especially on the module side, where LonGi is heading for? Do you know that from the top of your head, actually?
Well, for instance, the idea for this Hymo 5 is to
No,
start
in general.
with,
In general, the production, first the general production capacity, what you are planning by the end of 2020.
35 gigawatts on modules and around 70 gigawatts on wafers. This will be the numbers. And within this volume on panels, 12 gigawatts will be for this new solution, the Hymo 5.
Okay, so that means with this module capacity, you will be the world's largest module manufacturer by far.
I think so for the moment. If no one says anything else, yes. Yeah, this will be the idea with these numbers. The thing is, basically, we want to promote all this technology, keeping the technology of mono-PERC technology based on half-cutted cells and bifacial solution. This will be the main driver for us to reduce LCOE, basically.
Okay. Maybe, so let's see what kind of questions we have. Yeah, maybe there was one question, again, maybe you could also elaborate on that from your side, talking about micro gaps versus overlapping of cells, what others do. So why you have chosen actually this way?
Well, we had at the beginning, we had the option, I mean, at the beginning, I would say 2018, we thought to develop the overlap solution, but at the end, we need to think also in reliability. And from our side, we think this solution is not still mature because at the end, it's not well proved. And actually, you need to somehow, if you make overlapping with let's say with single, for instance, you need to cut many times, like 5-6 times the cell. So at the end, you are increasing the cost during the production and also somehow impacting the reliability because this is a new solution based. The cracks on this solution will be higher. Even you have some advantages on the overlapping solution, as for instance, the impact of the hotspots or the low current that you are driving. But from the other side, what we see, you can have a higher voltage and also a compromise on the reliability along the time with the expansion and contraction of the lamination during the lifetime of the panel. So for the moment, we are still relying on this solution by reducing the gap up to 0.6 millimeters already, which is not bad. Below that, we will be, I think, around 0.3 millimeters. We will be in somehow, for the moment, with this technology, will we be impacting the voltage creepage on the solution? So any problem with the voltage in between cells. Okay. So with this 0.6 millimeters. Yeah.
And I think the question, because it's a follow-up here regarding, was not regarding shingling, but it's rather this tiling solution which Jinko has, so that it is.
For us, at the end, the technology is a tiling solution. For us, doesn't bring us that much improvement, since we have a better control during production on the quality and reliability with the standard solution. This is the main reason for that. So we see some, let's say, some risk on the reliability along the time with this tiling solution. That's the main reason why we don't go to this solution right now.
Okay. What's I think sorry, the Klaus from Trina said he believes also in even larger modules, and they already use 210, and so what can you maybe elaborate a little bit on LonGi's roadmap? So what are your plans actually, because you are the master of wafers, so in the end actually you choose whatever you wanted.
Yeah, I mean, for the moment, as we can see after this presentation, our plans are to work on the N10 solution, so 182 millimeters, for all the reasons I mentioned before. I mean, from a logistic point of view, it allows you to increase the power density on the from a per container. Another important thing is the compatibility with inverter, because at the end, with, as I mentioned, with a larger wafer size, you are increasing the current. So if you cut ISO solutions with 210 millimeter wafer up to 600 watts, but based in a half-cutted cell, which means you are going up to 18 amps. These 18 amps will be somehow right now really difficult to manage by, as I know, by a string inverter. So you are somehow reducing the options you have in the market when you talk about the design of the installation. So you just maybe can base the solution or the installation in a central inverter, okay, neglecting all the benefits of the string inverter if it is maybe your normal solution. What we will do with the 210, as you mentioned, we can do it. Yes, we can do it. For the moment, we are relying on this 182. Maybe in some months could be an option, or in 1 year. But for the moment, our solution to the market is based in M10.
Okay, wonderful.
Because of all these reasons, I mean, higher current, higher voltage. So it has a big impact on the design and limits the design and the cost reduction. I mean, not always increasing the size is a positive way to, or a way to reduce the LCOE. And we can see it with basically with the mechanical parameters, so the dimension of the panel over 2.3 meters, and on the length side, and also regarding the electrical parameters, which are also important. For sure, you will install more. I mean, by panel you have more power, but you will install less panels per string. So at the end, you will need even. I mean, you are not having a positive impact on the BOS reduction through electrical point of view.
Okay. There were also some questions regarding reliability. So in general for larger modules, so is there yeah, I think because of the bigger dimensions, are there more unwanted bending or micro cracks? So how is the static load? And can you just give us some backgrounds also on certifications, maybe also?
Yeah. As I mentioned, for instance, our solution to talk about one of the solutions on the bifacial solution we are basing the technology in a glass solution, and always with frame. This frame, especially with this larger area, will give consistency to the whole solution. Okay, keeping a good behavior from a mechanical point of view. So this panel can withstand up to 5,400 pascals from a mechanical point of view. Another benefit of by using, especially with larger areas as this solution on panels for 500 watts plus, is the use of the glass solution. Is being known in the market that a glass solution has a better mechanical behavior than a lamination based in a glass and backsheet solution. So when we discuss, when we compare the glass solution in a bifacial module with a transparent backsheet solution, the behavior of the cells in the event they suffer a mechanical impact will be better in a glass solution lamination than in a glass backsheet lamination, and this has already been demonstrated by many tests. So that's why, I mean, we are confident on that. Actually, we have already passed all the tests regarding the mechanical load according to IC.
Okay, maybe one last question. We're already late. What about markets? So I think there's one attendee from India asking about India-specific products. So I think we all know that the Indian market is really price sensitive, and so these are high quality, high power, high performance modules. Are can you just look at the different markets they are, or talk about what they are destined for?
Yeah, I mean, actually, it's not India. It's not my market. I am familiar with somehow with the specific requirements in India, but I will say thanks to this new development, as I mentioned, we are reducing the BOS. So in the event the panel has a higher cost compared with other solutions, we are having a positive impact on the whole BOS. So we will be reducing all this. Actually, I mean, the plans for the moment, the plans for LonGi is to keep the Hymo 4 series with powers around 445, 455 watts, either in monofacial and bifacial, and also to implement this Hymo 5 series on monofacial and bifacial in worldwide. So there is no restriction regarding the markets. Will be more, I mean, depending on the requirements of the clients themselves, rather than us.
Okay. Okay, I think that's a lot. You have given us a lot of food for thought. Thank you so much, Juan Carlos.
Thank you.